Hype or hero? There's an increasing focus on hydrogen. Welcome this morning to TMC Online, our interactive session this morning on hydrogen, hype or hero. There's an increasing focus on hydrogen as an alternative fuel source, and in particular as a low emission fuel for heavy vehicles. In late 2018, the Australian and state and territory governments set the goal of Australia having a major global hydrogen industry by 2030. In 2019, governments announced a national hydrogen strategy, and in 2020, the Australian government's technology investment roadmap set a clean hydrogen as a priority low emissions technology, including for heavy vehicles. The ATA and our members have been active in recognising the potential for hydrogen to fuel heavy vehicles into the future, in addition to other technologies. Our submission to the government's technology investment roadmap included a focus on the need to develop an Australian hydrogen industry, developing a hydrogen transport network and refuelling infrastructure, incentivising the development of hydrogen heavy vehicles, and ensuring heavy vehicle design rules are not a barrier. Which brings us to our session this morning. Is hydrogen safe? Is it commercially viable? What can be done to accelerate a shift to hydrogen vehicles? Or is it all just hype? If you have any questions, put them in the chat box on your screen, and we'll put them to our expert speakers later in the session. We're fortunate to be joined this morning by two industry experts to explore the possibilities and potential of hydrogen. Roger van der Lee, CEO of HYDI, leads a team who have developed a hydrogen system which can be utilised for heavy transports. Roger has extensive experience in new technology ventures. Sandra Lau, its alternative fuels manager for Viva Energy, is responsible for understanding changing consumer trends and future mobility options to determine ways in which Viva Energy could participate in the future energy economy as the world transitions to a lower carbon future. For those who do not know me, I'm Sam Marks, the Transport and Infrastructure Advisor in the ATA's policy team, with a background in urban planning, politics and government. I've led the development of the ATA's recent submissions on hydrogen-related topics in consultation with our members. I'll now hand over to Roger to provide some opening comments.
Thank you, Samuel, and good morning, everybody. One of the key words in that opening address, and that we hear very regularly in respect to hydrogen, is future. And obviously that's an exciting prospect to go to a very powerful fuel that's absolutely clean and emissions-free. But as far as we're concerned, the future in terms of what we're doing is now, in that we have a system that provides a fuel supplementation system for diesel using hydrogen. So that can be seen by many as a transitional technology, but it delivers benefits straight away. And certainly it's a step on the path to introducing hydrogen as a main fuel in the future, whereby we don't have to wait for millions of dollars of investment to be made in the generation of hydrogen, generally from green energy, and building the infrastructure network. And on top of that, being able to purchase equipment that has the performance capabilities to haul long distance heavy loads that are a hallmark of the Australian transport system. So I'd like to, if I can, just share a very short presentation with you that addresses where we're at today and how it's relevant in developing the hydrogen industry. And I'll see if I can get this to go full screen for you. It's not coming up as a full option, I'm sorry. Just bear with me if you wouldn't mind. Okay, we're able to see that? So we're suggesting that hydrogen and diesel is able to deliver a profit and a productivity benefit immediately. So just talking about hydrogen, the hero, which is the subject of this session, 3 times the energy value of diesel. Obviously, that makes it very attractive. It's a highly efficient combustion process, which emits no harmful emissions. Water is the only emission, and it's produced from water via electrolysis with electricity. Now, that's not particularly new. That process has been around for decades, and there's a lot of major companies that and really large projects internationally that are looking to produce hydrogen from water based on electricity that's generated primarily from green energy sources on a large scale. So what are the challenges for the height of hydrogen? Obviously, the availability and the refill infrastructure for long-haul applications. Onboard tankage or generation to meet the range and load requirements, particularly in Australia where we've got long distances travelling through remote areas. Heavy vehicle technology, availability and cost. We need to be aware that the diesel fleet cycle, life cycle is 20 to 25 years. None of the new vehicle technologies, if they were available, that were able to deliver the range and load requirements that we require in transport in Australia are even currently on the market. So diesel as a primary fuel is going to be around a long time in terms of long-haul heavy transport. Another issue, of course, for hydrogen is safety. So if you start carrying or pressurising hydrogen in any sort of transport application, you've got a considerable safety risk, and we all know that hydrogen is very volatile in terms of being explosive. And the cost currently to produce hydrogen and distribute it is a lot more expensive than diesel, and that will be the case, we would think, for a considerable amount of time. So that's not to degrade the value of hydrogen. It's more about the practical reality of getting it into the transport system, making it commercially viable and available. So what's hydrogen on demand? It's a fuel supplementation system that reduces fuel, it increases performance, and it reduces emissions. And that illustration there was a fitment to a new Kenworth T610 in January of this year. And the second illustration is a fitment to a 2020 Mercedes 2663 Actros prime mover. So hydrogen on demand has no hydrogen storage. It has no hydrogen under pressure. The electronics control the hydrogen output because it's not a matter of more hydrogen is better in terms of getting the best results from both an emissions viewpoint and a diesel fuel saving viewpoint. It interfaces with the ECM, so the electronics are quite sophisticated in our product. There's no interdependence for the engine on the HYDI system. So if for some reason it's not operating, the diesel engine continues to operate as it would normally operate. You just don't get the benefits of the hydrogen input. And it's transferable to other equipment. So that's a retrofit unit that can be taken off that particular vehicle and put on another one, provided the engine characteristics or in terms of displacement are similar. A couple of experiences. So I should say that this has been under development for about 10 years, and it's been subject to some independent testing by the University of South Australia, where we have had results validated for up to 80% reduction in particulate matter. And our experience with a lot of our users out there is a considerable fuel reduction in the area of 8 to 13%, reductions in the use of AdBlue, and certainly extra power. And that's an example from one of our users in Western Australia on a 2018 Kenworth T909. The system is adaptable or can be retrofitted to equipment of any age, whether it's a new truck, as you've seen with the new current Euro 6 technology, right down to diesel engines that don't have any emissions control systems on them at all, and it's applicable to generators and other heavy equipment that uses diesel engines. So it maximises the existing diesel powered assets, and there's millions of assets in mining and in transport and in other uses around the world. reduces the carbon emissions consistent with the technology roadmap to net zero carbon emission objectives that the government has been promoting as its policy to meet the Paris Accord targets, and it pays for itself and contributes to profit by virtue of the money it saves from reduced fuel usage. So the economic and environmental benefits using hydrogen are achievable now in this form as an add-on and a supplementation to diesel-powered equipment. And we're pretty proud that that's been fully engineered and manufactured in Australia and is quite unique in terms of the sophistication with the electronic controls and the fact that it only uses water. There are no chemicals at all in our system, and that differentiates it from any other hydrogen on demand system that currently exists in the world to the best of our knowledge. This type of system is being invested in on a large scale by Cummins and some other OEM manufacturers. So we think that at the very least, it offers a particularly good transitional technology, introducing people to the benefits and the use of hydrogen as a clean and powerful fuel. So Sam, that's my opening comment and presentation. I'm happy to take questions on the way through or later in the context of the program.
Thank you, Roger. I'll throw to Sandra next to provide some opening comments, but just remind delegates and viewers that if you do have any questions, throw them in the chat box now, and so we will get to them. So, but Sandra, if you'd like to take us away.
Thanks, Sam. It's great to be here, and thanks for having me. Just to be totally honest, or open and transparent, while I am the alternative fuels manager at Viva Energy, and I look after so the strategy relating to hydrogen, biofuels, and electric vehicles there predominantly. I also sit on the board of the Australian Hydrogen Council, so I'm probably naturally going to side towards the hero argument in this discussion as my sort of position. In terms of Viva, just as a quick introduction to us as a company, we're the sole licensee of Shell petroleum products in Australia, and we supply about a quarter of Australia's liquid fuel needs. We own and operate the Geelong refinery in Victoria and supply a service station network of over 1,200 sites around Australia, as well as supplying commercial businesses, as you guys would be aware from a road transport perspective, but also marine, aviation, bulk fuels, chemicals, and a few other products. At Viva, we believe that there's a mix of fuels and energies required to assist the transport sector to transition to a lower carbon future, and this is very much a position of understanding fit for purpose technologies for different applications. So in terms of biofuels, there's a place for biofuels in very difficult to shift industries, electrification, and the different means of storage. So electrification and storage, whether it be and this is sort of mass storage, so it can be via pumped hydro, batteries, or hydrogen. And also the liquid fuels element that you need for some of those areas, and also gas. And our belief in this need for a range of the future is supported by our recently announced LNG hub vision, where we are looking at LNG at our Geelong refinery, as well as a solar farm. And all of this is to, support Victoria's and Australia's evolving energy needs. In terms of hydrogen itself, in terms of hype or hero, probably say I probably make a slight adjustment to some of Roger's points in my perspective in terms of some of the hype around it is really driven by the fact that I think that has a number of industries and a number of applications. So transport only one, and those rare items that can be used in chemical industries. It can be used as an export mode. It can be used for transport. It can be used as a gas blending in our natural gas mains. So the reason why I think there's so much hype is that there's so much potential, because it can do a lot to decarbonize our existing energy environment and across a range of applications. So it's not just transport or just in gas, or it's not just in steel manufacturing or ammonia production. It can, it ranges across the whole breadth of give it gives it a lot of momentum for the studies. And then hopefully what would happen, and this is the government departments like ARENA and stuff, and those that are, funding various pilots and studies around, is to, reduce the cost of hydrogen or forms of hydrogen from a dollar per kilogram perspective. And that's the drive of a lot of the government work, as we can see with the target of, hydrogen under $2, H2 under 2, as their vision and goal for a production cost. And what happens by having so much application for hydrogen is you also should be able to get an economies of scale and make it en masse. So it's not just for one sector or the other. So that is the ambition and the vision for hydrogen, that to bring down the cost of green hydrogen and essentially use it as a means of capturing Australia's plentiful resources in renewable energies, because essentially hydrogen is an energy storage mechanism, and that's what we're looking at. And it's the same as batteries and pumped hydro. All it is about storing renewables, and people use it in different applications. So in terms of its potential, it's huge. There, in terms of the hype, there is a lot of hype, and I think one of the big questions is timing on hype, because there's obviously a range of sort of timeframes for both technology readiness and commercial readiness, and that's probably part of that reality that has to be, that it's good to discuss. I think that's Sam. If you want to take it away with any questions.
Thank you, Sandra. The first issue we'll sort of raise today, I guess, is that of safety. If I am talking with someone outside of the industry about low emission options for heavy vehicles and hydrogen comes up, one of the first questions is it safe? So interested in both your perspectives on that. I think Roger made a comment about it being volatile, and I'm so interested in your comments on that, Roger, and about the HYDI unit as well. And then after that, I'll throw to Sandra if you've got any sort of comments that you can add as well on, the safety of hydrogen as a fuel option, as the refueling process, and also, whilst it's in the truck and if something goes wrong. So, Roger,
hydrogen's the lightest gas in the world and disperses extremely quickly. So hydrogen, the risk from hydrogen from a safety viewpoint comes when you have any quantity of it stored, and particularly under pressure. In the context of what we're doing, we're producing by volume, in terms of what the air intake is on a vehicle, a very small portion of hydrogen, and it's only it's used as it's produced. We have actually put a flame at the end of our unit, and we get a pop sufficient to frighten you, but it doesn't blow up our piece of equipment at all, because there's no storage of hydrogen within the system. So it's a very, very small amount. In that sense, we are going through a process with the Australian Maritime Safety Authority, which is a quite demanding process to be able to put the equipment into marine applications, which obviously have an enclosed engine room. And similarly, we have VSB 6 approval to be able to put it on vehicles across Australia, including those that carry any chemicals or other volatile type cargoes. So, in essence, if the unit that we currently use was producing hydrogen, and for some reason there was a malfunction that the hydrogen was to escape or to be exposed to a situation where there was any flammability, it essentially is quite safe, because there's no hydrogen there other than a very small amount that's in the tube that feeds into the air intake on the motor, that is available to ignite. There's a complete absence of any pressure or any storage of hydrogen volume. And that is a recognition on our part that there is a safety issue associated with having a condition where you do have a volume of hydrogen under pressure. Does present a risk factor.
Thank you, Roger. Sandra, do you have any comments or thoughts on general safety context, I guess, for hydrogen as a fuel for heavy vehicles?
Yeah, I think obviously. Yeah, I think safety is a great question, and obviously is at forefront of many people's. People remember the Hindenburg example, and which was, to summarize, a flying blimp on hydrogen, which, we're not talking about a flying blimp in this particular application. And the causes for that are widely rumored to be a number of, any theory, but some of the most accepted reasons for that was more about studio type of paint that was on the actual blimp outer coating. But that perception of danger with and safety concerns, still remains. And I think it's a valid, obviously a valid and important question to ask. I'll probably say that, it's been 40 years, Hindenburg, roughly, and technology has come a long way. There's, in terms of on road transport safety, particularly, there's a really great video that Toyota have put out actually on YouTube. So feel free to look it up, where it shows a bullet being shot at. So this is a carbon fiber fuel cell tank, and the tanks are the walls are probably just over an inch thick. And it actually shows in a slow motion replay what happens, which is essentially nothing happens at all. It's just like a release of gas. And I guess in terms of hydrogen's explosiveness, it is very explosive at a certain density in a certain environment with a spark right there. And one of the actual advantages of having it under pressure is, as Roger said, which is entirely correct, it's such a light gas that it will basically escape as fast as it can, and escapes and disperses even faster. So the likelihood of a explosion is actually quite low. And I'd probably point out, that there are inherent hazards with running gasoline cars at the moment, with the fuel that we run every day now, and yet no one thinks sort of twice about it. But that risk is, managed with the design elements of vehicles, and is accepted because we've been using it for so many years. And hydrogen is new, and therefore that awareness and knowledge isn't quite there yet. But as an example, I think 2019 there were 18. My numbers. Let me just double check my numbers. There've been hydrogen vehicles sold worldwide since 2014. And 2009, 18,000 fuel cell vehicles were sold globally. And that's obviously peaking since 2014, or since sales commenced then. And I'd probably ask the vehicle fires have you actually heard of from fuel cell vehicles, given that that they're starting to sort of have a lot of uptake in the market. So one of the biggest advantages in some ways is that under pressure the hydrogen disperses so quickly that your ignition source has to be exactly right quantity of hydrogen at X density in an environment for there to be a fire or explosion. And I guess that's one of the actually advantages over traditional liquid fuels, where gases actually pool, because gases are heavy from gasoline and stuff, so they actually pool in low points, and so the gas remains at the bottom of areas, and that's why you can get explosives off sort of traditional gasoline type fuels, whereas hydrogen, it just disperses into the atmosphere as fast as it can. And I think that's one of the positive things, but also keeping in mind that technology has come a long way. There's a lot of R&D, there's a lot of research. Every 2 years, there's a global hydrogen international conference for hydrogen safety that was run in Adelaide last year, actually, and I think next year's in Scotland. And that's where all these hydrogen experts come and share their technology advances, whether it be on seal material or design rules or what they found. And so I think there's a lot of goodwill and sharing within the global community about development of standards. And there are standards internationally for hydrogen design in transport use particularly. And in Australia, Standards Australia have a working committee called ME93 that's actually looking at mirroring. It was actually working on mirroring some of those international standards into the Australian standards. So that's been going for about a year and a bit now, a year and a half. And there's been a lot of effort put in. The chair on that standards committee is actually led by a Woodside person. So there's a lot of united industry input going into that through the different interested parties.
Thank you, Sandra. That was quite interesting and quite useful from my point of view, at least. I will turn to a question from our virtual floor. So on emissions, Tim Carr from Packard asks, Well, it says that so tailpipe emissions are always referred to. What about the total cradle to grave emissions? Would either of you have a comment on that question?
As I alluded
I'll take that,
to,
Sam. I think that's a great question. Oh, sorry, Roger. Was that?
Well, if you both
you have a go first, Sandra, and I'll come after you.
It's a great question because I think in the media, there's always a reference to tailpipe emissions, but the whole, real cradle to grave and analysis is very important when you're looking at holistic solutions for, a lower carbon future. There's no point, generating lots of emissions in one part of the manufacturing process and then, essentially having very little in another section, depending what the overall figure is. So in the US, there's some really good studies and released in terms of comparing battery electric vehicles, traditional fuel, diesel and petrol vehicle, cradle to grave emissions, as well as fuel cell. And fuel cell vehicles actually have the best outcome from a cradle to grave perspective. And most of that is due to the lack of sort of really, especially with the new technology on membranes and fuel cells, and the evolving technology there, but the lack of sort of specialty metals that goes into the battery electric space. So the battery electrics are a little bit obviously very advantageous over traditional fuels from a, makes all its gains on the zero tailpipe emissions, assuming that it's your electricity grid is, 100% green. But, fuel cells also, with that same caveat about hydrogen being produced off renewable energy, can actually be even more beneficial. But from a information perspective, the government actually have a website called greenvehicles.com.au or something like that, greencars.com.au. It's actually a government-run website where, from a passenger car perspective, you can pick your different passenger vehicles, and it actually shows you cradle to grave emissions and where, and whether it's tailpipe or manufacturing. And you can assess, a Honda Civic versus a VW or whatever models you wanted. So it is dependent very much on your generation of fuel. So whether it's obviously green or renewable, fully renewable generation to produce electricity or hydrogen, but there's clear benefits, I think, of hydrogen fuel cells in it as well, in the cradle to grave emissions, life cycle emissions.
In the context of what we're doing, hydrogen is enabling the reduction or the removal of particulate emissions and other greenhouse gases in particular at the source of the combustion. So whilst the percentage of particulate emissions are quite high, it's also amplified by the fact that currently in use in heavy transport is diesel exhaust fluid. By removing a lot of the emissions at the combustion stage and at the source, then we are removing a need for a reduction in the use of DEF, which in itself is pretty unfriendly in terms of its production process from a greenhouse gas point of view. So if we, as an organisation, are able to remove all of the emissions from diesel, which incidentally is our ambition, have a development path to go down that area, then the cradle to grave use of a diesel engine is looking very attractive in terms of being able to apply hydrogen. And there's another question there, Sam, where Ian has asked what is the percentage or portion of hydrogen being used in the engine. Currently it's very low. It's about 0.05% of the volume of the air intake.
Thank you, Roger. Thank you for answering Ian's question. We'll go now to Rob and Joshua's questions, which are also sort of relate to the hydrogen on demand product. So Rob says that Roger mentioned extra power results with hydrogen on demand. How is this being measured? And what impact does this have on overall engine durability and reliability, where engine manufacturers design specific engine models to operate on diesel fuel only?
That's a question that we don't have any scientific data on. It's all feedback from users of our equipment. So in my presentation, I had the new Mercedes 2663. That is a vehicle that's doing long-haul operations from the southeast of South Australia to Perth. Can't remember how many tonnes it's pulling, but it's a high load. It's a triple trailer. That vehicle is reporting that in inclines and hills and so on, he gave a couple of examples where without the HYDI on, he's doing 25 kilometres an hour. And with the HYDI on, he's doing 45. System that the using a gear or a half a gear testing that we've done to date with the University of South Australia. The repeatability of the torque characteristics on an old generator were marginal and a bit inconclusive by virtue of the fact that the test cycles were very short. We're looking at a further testing approach using a different organisation with more modern equipment, but that's a six-figure investment. Obviously, having those sorts of funds available to us at the moment is a bit of a challenge. We've got feedback from long-term trials on a metropolitan bus in Adelaide, the Scania, and quite unsolicited comment from the drivers of that particular bus compared to all the others validates the fact that it's a much smoother and a more powerful operation. We don't currently have the scientific data to back it up, but we expect to be able to do that very shortly.
And then on Joshua's question on the percentage of engine auxiliary power is used to produce the hydrogen. Sorry, did you answer that as well, or is that an additional? Do you want to provide a comment on
that? Our system is not specifically designed for a full hydrogen engine. It's designed to be used in conjunction with diesel fuel. Now, in terms of the power that we're using, it's only drawing about 10 amps from the battery system. In terms of engine longevity or wear, we've had test vehicles that have been using our unit. These are identical K100 Kenworths that we're running for a couple of years, over about 6,000 metres. And was absolutely clean. No results from Caterpillar on oil samples from a number of different applications that have been running with and without HYDI, same engine, same equipment, and there's 65% less residual soot in the vehicles that have been running hydrogen. So with that quality of lubricant being maintained for a longer period, we think that enhances the engine longevity, and people are looking at the possibility of extending their service cycles based on a much cleaner lubricant being maintained.
Thank you, Roger. I might turn for a moment to the question, a topic, I guess, of commercial viability. I think you both have mentioned price sort of in your presentations. I'll go to Sandra initially, I think. Price, I mean, from a trucking point of view, price is quite critical. And, it's also critical, as I think you may have alluded to, in terms of developing a hydrogen industry. Do you have a sense, or can you give us a sense of what sort of time frame we might be looking at? If you can crystal ball gaze.
Where's my crystal ball, Sam?
We're saying hydrogen is a viable, cost viable fuel source.
Yeah, I think the challenges with hydrogen, as Roger discussed as well, is there's a number of factors that need to make it sort of very commercially viable. But there's a lot of activity happening with a number of manufacturers declaring, interest in Australia, because where the hydrogen's advantage is in all the hard-to-shift industries. The one where you need energy density, you need high availability, high utilization of your gear. And so when it comes to the actual vehicles, I'd probably say that, there's obviously a number being rolled out overseas. There are some challenges with Australia with left-hand drive, right-hand drive issues in terms of import. I think that doesn't help us necessarily with a smaller market. In terms of specific timeframes, I would say that as a guess that between now and 3 to 5 years, we'll see more and more tests and trials. I think the Kenworth and have their truck arriving here, I think, this year, but that's associated with Deakin. So that's one of their trucks being tried in the US. I'm sure, Hyundai have a huge presence in Australia, and they're very interested in our market with their Nexo sedan or SUV that's come here, but they've also rolled out 1,000, or in the process of rolling out 1,000 trucks in Sweden. So from a timing perspective, I think many of the challenges are about raising confidence, whether it be safety, reliability, utilization, maintenance costs. And to do that, there need to be, more and more pilots and trials run. So in terms of costs, because it's, you're at the early end of the technology and commercial spectrum, they'll be quite high comparative. But this is where the government are coming in to sort of fund the difference. So a lot of the ARENA funding, for instance, looks at how much do you pay for a diesel vehicle X, and will fund the difference to get a hydrogen one, essentially, or battery electric, actually. So there are a lot of grant funding schemes at the moment that are very keen on bringing and trialing new technologies. And, this is the time where the government recognise that it's not that commercial, but they need real operators, actually, such as your membership base and interested parties to participate. Otherwise, the question of doubt and uncertainty in terms of things that need to be tested and tried remain. So the key thing for Australia and globally is actually less globally, because they're actually doing it in greater numbers, but definitely in Australia is about getting vehicles here, getting things tried and tested, getting pilot results, and then sharing it among the wider community, and then trialing something new. I think the Deakin initiative and partnership with Kenworth Packer is excellent, and then you've got FMG bringing in their buses into Christmas Creek in WA, so that will be an excellent trial in sort of a dry area, running miners and resources to and from camps and mine sites and stuff like that. So they're all leading towards greater commercialization, and the key, I think, to make it commercially viable is that you need to have the pilots on the ground testing the gear to raise that confidence. So as your confidence and actually as it naturally will, as the vehicle cost comes down, it coincides with the decreasing cost of the actual hydrogen itself. So it doesn't really work very well one way or the other, and you can't just wait for hydrogen to be cheaper and then look at it, because then the opportunity may have passed by, essentially, or it could be hard to transition for other reasons. So it's about paving the way and doing those pilots and tests in different geography areas with different type of customers under different applications that are really important, so that to build that not just experience but also confidence in the technology, confidence in the safety, also confidence in the refueling, the speed, the availability of hydrogen. It also tests the hydrogen supply chains to supply those markets. So all of that is really important. And when that happens, and I guess the question is on timing, it will be, the potential to be commercially viable is actually that. I think the reason why the government picked the H2 under 2 is that if hydrogen is below $2 from a transport perspective, it's actually more cost competitive than a diesel fleet, than operating on diesel. That's also probably assuming that the vehicle costs are roughly the same.
So very interesting. Thank you. Roger, did you have any other perspectives you want to add to the cost sort of viability question, or even the cost viability of your units?
Sorry about that, a microphone would help. Broadly, I agree with Sandra's position. I think there are some unknowns as to what the hydrogen consumption rate will be in terms of whatever the new vehicle technologies are. And of course, the timing, given that we're a small market, the nature of our geography and population and distance between centres, it will be interesting to see how long that takes to roll out. And I could give some examples of other technologies where there's a lot of hype, and that's taking a long time to get going as well, and that's autonomous vehicles. But that's another story. In terms of our unit, obviously, the variables are what are you paying for your diesel? What does your vehicle use in terms of its consumption rate? But in broad terms, the modelling that we have, if you were paying $1 a litre for your diesel and you were running a prime mover of a B-double type configuration, typically running between the capital cities in Australia, our calculation is that the unit pays for itself in about 240,000 kilometres by virtue of achieving a 9.5 to 10% fuel saving. Beyond that, it's a full profit situation. The running costs of this particular unit are minimal. It uses 1 litre of water every 37 hours on a 15-litre machine, and it needs a couple of very, very minor services for a filter and a recirculating water pump to be replaced once a year. So the payback is extremely attractive. And that's notwithstanding the other benefits of running a cleaner engine, perhaps looking at your service cycles and all of those associated costs. And the vehicle's got more time to be on the road.
Thank you, Roger. We have a question from Peter, which I might throw to Sandra in the first instance, which is how will we see hydrogen road transported in bulk? Will the volume delivered be less because the tankers will be heavier?
That's a great question as well, because one of the biggest technology issues actually that continues to advance is on hydrogen storage and handling. We know the potential of it, but the difficulties of hydrogen are well known as well in terms of because it is so light, it actually has to be stored, at a negative 270 something degrees to be in liquid form to give it that energy density during transport, which obviously takes energy, or you can transport it as a gas, but then obviously transport a lot less. And this is why you see a lot of research going into other hydrogen carriers like ammonia, which is obviously at standard pressure and ambient temperature. And it's actually also because it's an NH3 molecule versus a H2 molecule, it's actually more energy dense as well, which is why if you look at the export market, which would be biggest bulk transport that you see, there's really a shift towards looking at ammonia as a carrier, and then a technology, and this is why that CSIRO breakthrough in 2018, I think, end of 18, was so momentous, because their breakthrough was to have a membrane essentially that cracked ammonia back into hydrogen, which would mean that you could transport bulk hydrogen in an ammonia form overseas without that issue of pressure and temperature, and then you could convert it on your site at use. So at the moment, I think as we ramp up the industry and as the technology evolves, I think we'll see hydrogen transported in a gas state for now, also because of the cost involved. So while the emerging market grows, we'll obviously want it to meet as commercially opportune or the best commercial option as possible, because there's so many other factors. So I think it would be transported in bulk. The difference is probably, or in gas, but the difference is probably where we're used to. It's kind of that. I probably like to use an analogy of the electricity market going from a centralized to a decentralized distribution system. Whereas, in the past, we used to say one huge refinery or one big coal plant that distributes all the electricity or all the fuels from one big spot. Whereas, in the electricity market, we're seeing that fragment out with, the rise of home solar, wind farms, solar farms, distribution being, generation being quite distributed now. And there's a potential that depending on application, you would, rather than having one hydrogen generation plant per city or state, you could have multiple ones. And so you'd have more of a hub and spoke model depending on your environment, where you're trying to supply to, your generation volumes. So I think those distribution mechanisms will also be slightly different going in the future, and probably longer term, I think it would probably go to be a non-gas state just because of the density required, that makes it more effective. In terms of volume, divided less because the tankers will be heavier. I don't actually know the answer to that. I'll have to take that one on board and, try and get some answers to that one. I couldn't actually claim that much knowledge on that particular one. The only thing I'd say on that is keeping in mind that the energy density of hydrogen is really high. So, for instance, on a passenger vehicle where you might need 50 litres of fuel to travel 500 k's, you would need 5 kilograms of hydrogen. For a bus, for instance, it might be, I think a bus is around 35 kilograms of hydrogen for maybe a 250, 300k loop, something like that. Yes, the energy density of hydrogen leads to a slightly different volume requirements.
Thank you, Sandra. We have a couple of questions for Roger now. So Tim, the editor at Diesel, has a question about what are the implications for vehicle warranty of fitting one of these hydrogen extra power systems?
Yes, that's a question that we have encountered, and to that extent, we've incurred interest from a number of OEMs, and we've signed some non-disclosure agreements with those organisations to share some of our data and our information. There's a well-known case in the USA regarding warranties in terms of third-party equipment causing or being shown to cause a breach or a fault that has led to a warranty claim on equipment. And the outcome of that is that the manufacturer needs to be able to demonstrate or show that the impact of the third-party equipment had a direct cause for a failure of the equipment that led to the warranty claim. We, at this stage, are confident by virtue of a number of millions of kilometres of testing over years and our current customer base. We've not had any claim whatsoever or any cause for concern in respect to a claim. Certainly, we are insured for anybody that might want to make a claim in respect of our equipment or the very low percentage. And I said earlier that's only about 0.05% of the air intake going in, or hydrogen going into the engine. So at this point in time, it's not an issue that we needed to address, and it's an area of discussion and exploration as far as at least some of the OEMs are concerned. You'll probably be aware of the fact that Cummins is doing a lot of work in developing hydrogen systems associated with their equipment. And certainly our testing, both at the university independently and with our users, is indicating that there's no increase in engine coolant temperature. In fact, they're running a bit cooler, and exhaust gas temperatures that we've measured have not been higher. So there doesn't appear to be any heat stress or any of those measurable parameters that indicate it's detrimental to the engine, and we are reducing a lot of the soot and carbon particles from the internals of the engine. So at this point in time, there's been no recognition at all of any issues to do with the small amount of hydrogen that we've been introducing that's having a detrimental effect on engines. In terms of
just to support that, Roger.
Sorry.
So I just want to say, just to support that, there's a couple of universities that are investigating using diesel engines and converting them and using majority hydrogen in them. The issue with the hydrogen in those diesel engines is about, it doesn't ignite on compression for your pistons, and so they're looking at other ways of getting it going, I guess, essentially. But I would concur, Roger, that there's no evidence of, your technology and I think shown by the research going on in other areas on how to utilize existing, engines on hydrogen. There doesn't seem to be a huge concern at all. It's more about the efficiency, the energy output, soot, particulates coming out.
Yeah, and certainly, we've had a number of people that have bought brand new trucks that have fitted our equipment in the showroom before they've been delivered, and there's a confidence out there with those early adopters to the extent that there isn't an issue.
Thank you both for that. We have another couple of questions on on the HYDI units. So a question from James about maintenance, what maintenance is involved on the units, and what's the expected life of the units, and is it cost effective in that way? Do you want to answer that one, Roger?
Yes, the life of the unit, we guarantee the case for 15 years. It's a 2mm fully welded 316 stainless steel. The annual requirements for it is that it's got a very small, low-cost filter that we put in to the unit as a safeguard, because it only runs on distilled or demineralised water. We like to safeguard the electrolysis cell from getting any impurities in it. And there's a very small water pump within the unit just to keep the water circulating. Both of those items are minimal cost, $20 and $50 odd each. So there's a service that we recommend every 6 months to replace the filter at 6 months and replace the water pump at 12 months. The only other maintenance is the PEM cell, the proton exchange membrane cell. Utilises a membrane that's produced in the USA, and that has a life of 10,000 hours. So at 10,000 hours, we would change. We believe it has a life of that. We've used them for much longer, but as a preventative maintenance perspective, we've replaced the PEM membrane at 10,000 hours, and that's an exchange whereby we take the old one and provide a new PEM with a new membrane in it. So however long it takes to do 10,000 hours. Both of those services are relatively low cost. In terms of the consumables, I mentioned earlier that it uses distilled water at the rate of 37 odd hours for a 15-litre engine. And beyond 1 litre, the tank has a 2.5 litre tank, or you can put a header tank on it, which is much larger. So it doesn't need attention very often, and demineralised water is pretty cheap. Did I answer all of the questions in terms of that?
Yes, I believe so. There is another one from Neil for you as well about what is the weight of the unit that is fitted to the prime mover.
The standard unit, which you can see back here, this is a horizontal one. There's also a vertical version that was in the photographs in the presentation. They weigh about 25 kilos.
There you go.
It's about 640 or 50 millimetres long or high, depending on whether it's vertical or horizontal, by about 240 by 200 millimetres.
And just, out of interest, are there many on the road? Can you give us a sense of that? Or
we've got, I think we've got about 15 or 20 out in the field currently. Most of those are on the road. One's on a generator in the Pilbara. And we have one in a marine application, but we're not pursuing any further marine applications until we get our approval from AMSA, the Australian Maritime Safety Authority. That unit is producing excellent results, whereby we've got that vessel's got 2 engines in it, identical engines, operating in identical conditions under the same load. One's with HYDI, one's without, and it's a noticeable difference in fuel consumption versus the one with HYDI versus the one without.
Thank you for that.
The other thing, Sam, that's not so relevant, I suppose, for our market is that we're actually getting a lot of inquiry from overseas, in particular from Europe and South America for heavy transport and mining for the latter. So we're on the verge of sending our initial units to international destinations.
Very interesting. A question for Sandra from a broader, some of the broader issues with getting hydrogen as a viable sort of fuel source, and the application of heavy vehicles and the like. From if you were to what would you recommend that governments need to do to encourage that shift? I guess would be my question. Yeah,
I kind of think that the one really great thing on government side is that, which is quite rare actually, governments, is there is quite a consensus across both local, state, and federal levels in terms of getting a hydrogen economy going. Just because the benefits from a a low emissions future, but also as well as a growth in GDP with future export potential to markets like Germany or Japan or South Korea are huge. So that there's a huge push on from a government perspective, and they recognise that transport is actually, like, it's spoken about a lot as an option for hydrogen, and it is a very promising one. It's also actually quite a very difficult one to get going off the ground. So I think some of the things that they are doing now, like ARENA have their 70 million future fund out to look at the infrastructure. New South Wales have a zero emission bus trial going on for both electric and hydrogen, where they are looking at funding the difference between diesel and a alternative fuel vehicle. I think Victoria has announced something similar just a couple of weeks ago. So I think there's a number of local, in terms of state and federal government, about trying to understand how they can help initiatives get across the line from a funding perspective. So I think there is a lot of effort going on. What the government can't do is pull the parties together, and that's what we and everyone listening can help do, is put collaborative groups together to try and come up with initiatives, because it's very difficult to run initiative by yourself, because are you a OEM maker, so are you providing the vehicle, or are you the operator, or are you the generator of the hydrogen, or the retailer of the hydrogen, or supplier and infrastructure? So it is very much about finding good industry partners to do initiatives with, and we can see that across the board, that most initiatives that are being executed are being done in groups of companies. And I think from a government perspective, they are supportive of that. They're supporting that from a trying to test different parts of the market, trying to put some funding to it. They probably, to be honest, the amount of money they're putting into it is probably not enough. I think, as an example, I think for renewable solar to get the traction and become such a viable proposition now, I think they put something like 500 million towards it from a federal government grant perspective through corporations like ARENA and the CEFC. And we know that a solar panel is a lot less complex than both a fuel cell vehicle and infrastructure and everything associated in between and outside that scope. So the amount of funding would probably need to increase. But I think from the fact that there's so much broad government consensus, is quite rare, especially in the energy market or energy fields. If we look at gas, electricity, or coal, or anything else out there, there's a lot of debate. Whereas I think there is consensus, and you can see that each of the states are trying to do their own initiatives as well, give their own funding grants to support their state to develop the industry that is recognised as having a lot of industry growth potential. So I think they're doing good stuff at the moment. It's probably just a matter of, to be honest, like anything, is more money. But in COVID times, money's needed everywhere across all parts of society, really. So it's about being realistic about how much we need at this point in time and how much we need going forward, I think. But I think ARENA's Life, which is the main grant funding mechanism through the federal government, they were just extended a month or 2 months ago. They were meant to end next year, but they've been extended for I can't remember how many years now, but with additional funds to allocate. So that's a really positive step in the right direction.
Thank you for that, Sandra. We are just about out of time at the end of our session, but I'll throw a final question to Roger from the floor. So Daryl has asked if you have completed ROI analysis on the prime mover products, and if so, what were your results?
Okay, I think I mentioned earlier, but perhaps the questions come from someone that's coming late. On the basis of paying $1 per litre for your diesel, on the basis of having a consumption rate consistent with most prime movers travelling interstate in Australia, and running a B double of the normal capacity weight, the calculation on a 9.5 to 10% fuel saving, which is the average that we're achieving with most of our users, the payback is 240,000 kilometres, and beyond that, the unit is then delivering a profit return in terms of the savings on fuel and potential savings on service cycles and the like, based on cleaner oil, less consumables, and so on. And also there's a bit of a productivity gain, whereby we've got reports from users across Australia that are having to stop for fuel less often. One particular example with a local company here is that he's able to travel from Penaroo to Brisbane without a fuel stop. A sister truck carrying the same sort of loads can't do that. So that in broad terms, obviously there are variables concerned with each operation and what the fuel cost is, but within 240,000 kilometres or so, the unit has actually paid for itself, and we're saying the life of the unit is 10 to 15 years, and if you don't keep your truck that long, you can take it off and put on the next one.
Thank you very much. Thank you, Roger and Sandra, for your time this morning. I found that quite interesting and useful. If I missed your question or you've thought of a question sort of now or a bit later, you can reach out to Roger and Sandra directly through the TMC online platform, through the community function, so make use of that. I believe there's also a HYDI on-demand video about the product, so you can watch that as well. I watched that this morning. It's quite informative. And then, yeah, there are obviously more on-demand sessions that you can watch. There's another live session a bit later this morning, so watch out for that. But thank you very much, Roger and Sandra. I thoroughly enjoyed that. I hope you did too. And thank you, everyone, for being part of TMC Online.
Thanks to TMC for the opportunity.
Thanks, Sam. Thanks, TMC.